Welcome to grade 10, lesson 7 of IntoMath. Grade 10. In this lesson, we're talking about expressions that contain exponents and can be simplified. First of all, you would have to review exponent laws for integer exponents. Any number except 0 to the power of 0 is equal to 1 when we have the same base, different exponents, and multiply the powers, we add the exponents. When we divide the powers, we subtract the exponents. When we have an expression raised to the exponent, every part of that expression has to be raised to the exponent. A fraction raised to the exponent has to have every part of it being raised to the exponent. If the exponent is a negative exponent, then the base is flipped. The reciprocal of the base is taken and the exponent becomes positive in the denominator. The denominator cannot equal to 0. And if the fraction is raised to the negative exponent, it has to be the reciprocal of the fraction raised to the positive exponent, where b cannot equal 0 or a cannot equal 0 in this case. The nth root of a number, any number a, is a number that when raised to the exponent n would equal that number a. N should equal 2 or greater. In the radical expression is the one that contains the root. N is called the index of the radical. So nth root of a equals b, then b to the exponent n is equal to a. When there is a root without a number, without an index, it's a square root. It means the number was squared before and now it's square rooted. When n equals 3, we call it a cube root of a number. If n is an odd number, then any value of a satisfies the expression nth root of a. If n is an even number, then a is greater or equal to 0. For example, 2 to the exponent 5 is equal to 32, therefore fifth root of 32 is equal to positive 2. What if we wanted to take fourth root of 81? That would equal 3 because 3 to the power of 4 is equal to 81. Could we possibly take the fourth root of negative 81? Is that possible? It's not. It's undefined. Since no number, when raised to an even exponent, will ever give us a negative result. Because even if you do negative 3 to the power of 4, it's positive 81. Negative 3 times negative 3 times negative 3 times negative 3, 4 times. And positive 3 obviously is also 81. So you cannot take an even root of a negative value, but you can take an odd root of a negative value because it's been multiplied. A negative number was multiplied an odd number of times. Now let's take a look at rational exponents. If a is a positive number, m over n is a fraction, where m is a whole number, n is a natural number, then the following stands. And you could take a look at the examples here very closely. It gives you different situations that show you where each number from the rational exponent goes. Properties of powers with rational exponents. If m over n is a positive fraction, then 0 to m over n is equal to 0. If m over n is a negative fraction, then 0 to the power of m over n has no meaning, or it's undefined. Because if you decide to take a negative, say 0 to the power of negative 2 over 3, right? Then you have third root of 0 to the power of negative 2, and then this would end up being 1 over 0 to the power of 2, and we cannot divide by 0, it's undefined. Therefore, this expression is not possible. So if a is greater than 0, m is a whole number, and then k are natural numbers, then the following stands. So even if you multiply both parts of your rational exponent by the same number, it just becomes part of that number when it's transformed into a radical form. You also need to remember that integer exponent laws apply to rational exponents. Let's use what we just learned to try and simplify these expressions here. So in this first example, we have the same base, we multiply the powers, we can add the exponents first. So I keep the base and I add the exponents, minus 1 plus 2 minus 3x, and all of this still squared. Now I will simplify this, collect like terms. So 3, 5x, subtract 1 plus 2, subtract 3x, drop the brackets, and then 5x and negative 3x, negative 1 and positive 2 go together. So we'll get 2x plus 1, and all of this squared. And now we need to do the power law. So all of this expression is multiplied by 2. So 2 times 2x plus 1. And then we get 4x plus 2. And that's our final answer here. Now in this one, we have to look closely at what's going on, where we can work with different properties and laws to simplify it. So we can clearly use the distributive property here to distribute this over each term inside the bracket first. So that's what we're going to do. This is a to the power of 1. A to the power of 1 times a to the power of 2. We're adding the two exponents and keeping the base. A is 3 over 2, 1.5. B, 1 over 2. Plus, then we're going to keep a to the 1. And then b, half plus half is also to the 1. We're multiplying, but we're adding the exponents and keeping the base. Now, let's do the power law here. So we'll get a to 1/2 times 3, which gives us 3 over 2. B to 1/6 times 3, which gives us 3 over 6, and reduced 1 over 2. Now we have this negative in front of the bracket, which means when we drop the bracket, it affects this whole thing. So all of this becomes negative, and we get a 3 over 2, b to 1/2, plus a to the power of 1, b to the power of 1, subtract a 3 over 2, b to 1/2. Now this and this are exact opposites. They are gone, we reduce them. And then the only expression that's left is a1, b1. And since these are exponents of 1, we never even write them, we just keep it as a, b, and that's the final simplified expression. This is it for this lesson. Hope you enjoyed it, and thanks for being with IntoMath.